I am Anil Kumar. Welcome to our series on trigonometry. We'll consider all the angles in radians in this particular video to evaluate simple trigonometric ratios. We'll begin with understanding or rather reviewing the cast rule and the special triangles to answer the questions. Here are 9 questions for you to answer. You can pause the video, solve, and then look into my suggestions. Now let's begin with the basics as some students might have forgotten while working in degrees how do we work with radians. Basic rules are same, cast rule and SOHCAHTOA. Cast rule, as you remember, is telling you in which quadrant the ratios are positive or negative. So we will write the cast rule starting with quadrant 4. A here means that in quadrant 1 all are positive, quadrant 2 only sine is positive, and its reciprocal cosecant will therefore be positive. Quadrant 3, tan and cotangent are positive. Quadrant 4, cosine and its reciprocal secant are positive. So that's clear. Now, SOHCAHTOA basically is sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. Two triangles to consider are 30, 60, 90. Now, when we say radians, in that case, 30 degrees is basically pi by 6. You can convert by the conversion factor. And 60 is pi by 3. 90, of course, is pi by 2. In that case, the ratio of the sides is 1 to square root 3. Hypotenuse being 2 units long if base is 1 and the altitude is square root 3. The other triangle of interest is pi by 4, isosceles right triangle. In that case, pi by 4 means 45 degrees in radius, correct? Sides are equal if the sides are square root 2 and square root 2. In that case, the hypotenuse is 2. So these are used to evaluate. So I hope that concept is absolutely clear. We'll only work in the domain from 0 to 2 pi in this particular video. Not necessarily, since what we did here was we extended, you see that. So we wanted to work in this domain, but we have removed the restriction and we'll be working in for any angle, correct? Okay. But definitely, we are going to use special triangles to answer all the questions. Let's begin with the very first one and understand the strategy. We need to evaluate sine pi by 3. So, whenever you want to evaluate, do two things, and that is consider cast rule. 1. Sine pi by 3 means an angle in quadrant 1 means this value has to be positive, correct? So let me write down the question first and then I'll write down the value. So we want to find what is sine pi by 3 equals to, correct? So first thing we figure out that it is positive since you are in quadrant 1. Pi by 3, draw the special triangle, right? So in this special triangle of pi by 3, I'm going to draw it again and again so that you remember. That is kind of very important. The sides are 1 to square root 3. Now, sine, as you know, is the ratio of opposite to hypotenuse. So this is equal to square root 3 by 2. Makes sense? Positive. Now, we have to look into cos 2 pi by 3. Cos 2 pi by 3 means, again, the cast rule, right? Cos 2 pi by 3 will be in quadrant 2, correct? Quadrant 2, cos is negative, correct? So we can write down cos of 2 pi by 3 is going to be negative since you are in quadrant 2. Now, what is the related acute angle? The angle which we are considering is pi by 3. So that's the triangle we have to look into. The same triangle. Purposely, I'm taking one triangle for all the three examples. Now, cos is the ratio of adjacent to hypotenuse. That means 1 over 2, but negative. You see that? So, we have used SOHCAHTOA and the cast rule. Now, let's look into the third case. Again, sketch the coordinate system. Tan 5 pi by 3. 5 pi by 3 means, well, 6 pi by 3 will be full circle. So this is 5 pi by 3. As you can see, the value will be negative, right, from the cast rule. So we can write tan 5 pi by 3 should be equal to negative because you are in quadrant 4. The related acute angle again is pi by 3. And tan is the ratio of opposite to adjacent, and therefore it should be square root 3 with a negative sign. So I hope you understand how using one special triangle, which is pi by 3, pi by 6, pi by 2, we have solved the basic trigonometric ratios in different coordinates. Now, that is your foundation. Let's begin with the other question. Secant 7 pi by 6. Now, secant is reciprocal of cos, correct? 7 pi by 6 means what? 7 pi by 6 means that you are a pi by 6 ahead of the straight line. So that is 7 pi by 6. And clearly, we are in quadrant 3, right? So this is also quadrant 3. If you apply the cos rule, we know secant being reciprocal of cos is going to be negative. So we can write down here secant 7 pi by 6 has to be negative. It is basically equal to negative secant pi by 6, right? Because the related acute angle is pi by 6. So let's make our triangle for pi by 6. Let's look into it. How does it work out? So this is pi by 6. Here we have pi by 3. Triangle 1, 2, square root 3. And clearly, secant is basically equal to reciprocal of cos, right? Cos was square root 3 over 2. This will be 2 over square root 3, but with negative. You understand? 2 over square root 3. Is that clear to you, right? Let's move forward. Question number 5. Sine 22 pi by 4. So let's begin by understanding where you are. 22 pi by 4 means if I start with pi by 4, 0 will be here, then one full circle will give me what? 8 pi by 4, right? And two circle, 16. Do you understand? Third circle, 20, correct? And then 21, 22. You are right there. You understand 22 pi by 4, correct? So 5 full circles. So 8. So now let's look into angles which are more than 2 pi. So we have sine 22 pi by 4, correct? Think like this. If I make one full circle, in that case, it will be how many pi by 4s? It will be 8 pi by 4, correct? But we have to go more because it is 22. So if I make another circle, it will be 16 pi by 4, correct? Now we are looking into 22, which is still more than 16, right? So 16, let me just change the color here. 16 plus 4 pi by 4 makes 20. And there we have 21 and 22. So we are right there. So that is the position where we are. Now the coordinate point of this position, if you consider a unit circle, in that case, this is going to be 0 and minus 1. Sign value is this negative 1. You get the whole idea. So this is as good as writing minus 1. Once you know the position straight away, you can write down the answer. Is that clear to you, right? So in this case, we kind of use the unit circle. Next example, question number 6. Change this to sine 101 pi by 2. So 101 pi by 2 means what? So one full circle is how many pi by 2's? 1 pi by 2, 2 pi by 2, 3 pi by 2, 4 pi by 2. Do you see 4 pi by 2, correct? So 100 will also come here, right? Multiple of 4 will be 100 pi by 2. Is that clear? 101 pi by 2 means you are in this position, correct? So this is same as sine pi by 2. Periodic function, it repeats. Coordinate point here is 0 and 1, and therefore this value should be positive 1. Do you see that? So when it comes to the coordinate axis, it is good idea to use unit circle, right? Then the coordinate points on a unit circle will always give you sine and cosine values, correct? Perfect. Let's move on to the next question, which is question number 7. So now we are considering negative angles. Negative angles means clockwise rotation. Perfect. So let's take this up. We are now talking about secant minus 11 pi by 3. Now, minus 11 pi by 3 means going in the clockwise direction. So, one full circle will be in this direction if you are going minus 6 pi by 3, right? 6 pi by 3. 11 means 1 less than 12. So, you go one more and you reach here, and that becomes minus 11 pi by 3. Makes sense? 1 less than 12. So you could rewrite this as secant pi by 3. You are in quadrant 1, value has to be positive. And now make your triangle. Perfect. Pi by 3 is this angle where the sides are 1 to square root 3. Secant is the reciprocal of cos, so it is 2. So we get this value of 2. Perfect. I hope it is making sense, right? Question number 8. We are looking into tan minus 17 pi by 4. Let's understand where we are. Minus means clockwise. One full circle means 8 pi by 4, correct? And another circle will mean 16, and one more means we are here, correct? So that is minus 17 pi by 4, right? Since we are in quadrant 4, the value has to be negative, correct? So tan minus 17 pi by 4 is equivalent to minus tan pi by 4. Makes sense? So the value is negative. You can draw the triangle. The sides are 1, 1 for pi by 4, right? In that case, square root 2 is the length of the hypotenuse. So it is negative 1. Perfect. So I hope the concept is clear to you. Some more practice may be required. However, here we are at the end of this particular set of 9 questions. cotangent minus 5 pi by 4 is the question for you. You can pause the video, figure it out. As you know, minus 5 pi by 4, right? So you have to go in this direction 1, 2, 3, 4, 5, right? So you're right there, and this is minus 5 pi by 4. So we moved in this fashion, right? Minus means clockwise. So we can write cot of minus 5 pi by 4 is basically equal to. Now you are in quadrant 2, so the value is negative. And the related acute angle is pi by 4, is cot pi by. Special triangle, smaller legs are unit length each, right? In that case, we know what the cotangent value will be 1 with a negative sign since we are in quadrant 2, applying the cost rule. So I hope with this you have a fairly good idea of how do we evaluate trigonometric ratios when the angles are given in radius. We also saw different ways of finding out in which quadrant you are for the given angle. Once you know where you are, you can apply the cost rule and then use the special triangle to find the exact value. So this can always help you to answer questions without calculator easily. I hope it makes sense. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your valuable time and all the best.